So again, first up is Kevin Pellett. He is with a stock assessment biologist at Fisheries and Oceans Canada, working out of the South Coast office in Nanaimo. And Kevin worked on Cowichan River predation studies as part of the Salish Sea project.
All right. Thanks, Corey. So I'm excited today to have the opportunity to talk to you guys about some of the work we've been doing, and more importantly, where it's actually leading, and some of the results we're starting to collect. So I'd just like to recognize all the different groups that contributed towards this project. It's been fantastic for me. It's super interesting work. And a lot of my background is based in recreational fishing. That's kind of where I got my interest in fisheries work. And here's one of the places I really like to be, is sitting on a boat actually fishing. This shot's actually from Barkley Sound. So we don't have a lot of time to really get into the meat of how these projects were conducted, but I'm more or less just going to talk to you about what we've found. So one of the things you may have heard about in 2016 was this dramatic loss in Chinook salmon smolts as they head downstream of the Cowichan River. And in 2016, from the top end to the bottom, we estimate only 25% made it, 75% didn't. So massive loss, which begged the question, okay, why? What's causing that? So we repeated the study again in 2017, and what we found was that when the flow was a lot higher, so the difference between 2017 and 2016 is indicated in this graph. The shaded box represents the actual smolt migration period. The flow is 6 times higher in 2017, and our survival, instead of being 25%, was up around 70%. So there's obvious correlation there. Something's going on with flow, and whatever flow improves, whether it's the speed of their passage downstream or what it might be, is apparently influencing their survival. We suspected in 2016 a lot of that was due to predation, so we decided to look at that further in 2017 and actually see what's going on. So one of the stories you may have heard about 2016 was these raccoons that ended up with pit tags running across our arrays. We thought, hey, well, why don't we actually try and put antennas around other animal paths or haul outs or wherever they might be, and see if we can actually detect tags inside of those animals and see if we can find out who's actually doing the eating, so to speak. And so 2017, we let about 5,500 tags go, and we set up this. So this is a shot at the top of an otter slide. So otters have these predictable paths where they come in and out of the water. And right at the top of this slide, you can't see it, but it's buried in the dirt, is an antenna scanning for pit tags. And the read range in it's about 2 to 3 feet above their head. So it's quite a powerful antenna. And here we have 3 otters on top of this antenna. So we paired these with trail cameras to actually see, okay, how many otters crossed the antenna, how many tags were inside of those otters. And it turns out that after we scanned 118 different otters, or otters over 118 days, 59 raccoons, 7 martins, we didn't get any tags, but that may not be unexpected given the fact that survival was so much higher in 2017. So we had less in-stream loss, likely due to higher flows. So these guys, for the time being, are kind of off our list. Another thing we looked at was trout. So everybody said, okay, well, it's all these brown trout in the Cowichan River that are hammering on these Chinook smolts. That's where your loss is. We didn't get a lot of trout, again, because the flows are just so high, 6 times higher than what we're used to. So it was difficult to capture trout, but we ended up with 28 trout. Of those 28, only 5 actually had evidence that they even consumed juvenile salmonids. So when you break that down, the largest consumption we found was 4 per trout. So Nathan might actually shed light on this later in his talk, but he's got consumption rates of 50, 80 smolts per trout in other areas. So this, again, they appear to be predators, but perhaps not that significant. I'll show you this. This is just kind of doesn't make much sense when you initially look at it, but essentially this right here is our pit tag array in the lower Cowichan River. So this is something you may have heard about. This is what lets us track pit tags coming down the river and adults coming back. There's 6 antennas end on end here, and each tag, as it passes over antenna, actually registers which antenna it was on. So across the top is the antenna numbers, and you can see up on May 25th, this one tag was registered once on antenna 6, which is not abnormal. It was released on May 24th, so this is what we'd expect. But the other, you can see kind of down in the meat of it there, there's thousands of tag hits on some days, and it looks like they're going back and forth across those antennas. So this tag is literally there for 2 to 3 weeks after, going back and forth across these antennas every day. That's not a normal behavior. That's not a live fish. That's something else. And there's only 2 things that live in those antennas. 1 are signal crayfish, and 2 are sculpins. Those are the only 2 things that are, in my opinion, capable of doing that. And not only that, but we found this at 2 different sites in the Cowichan River last year in 2017. We had the same result, tags coming and going every day. So I think, although we weren't able to nail it down, I think these 2 have kind of raised to the top of the list. And given how many crayfish and how many sculpins are in the Cowichan River, it would certainly go a long way to explaining why we'd see these consistent losses throughout the entire length. There's thousands and thousands of these animals. This is another one, great blue herons. So this is probably the most exciting kind of result of the pit tagging work and predation work in 2017. Some of you may have heard about it, but essentially what happened is we sent a UBC student down to a heron rookery in the south side of Cowichan Bay. There's about 90 animals nesting there. And underneath the rookery, they actually took a mobile scanner and looked for tags. And he came up with 406 pit tags that all belong to us from the Cowichan River. Actually, 405 did, 1 didn't. But when we went back and looked at those tag codes, they were represented from all 4 tagging years, which is incredible. And also several of our tagging locations, most were from the river, a few were from the bay. But when we go back further into those tagging records, 2016, which is the lowest flow year in the Cowichan River, the lowest flow that we studied, accounted for 62% in those tags. So again, there seems to be, again, that correlation between low flow and high predation. When we go back through and actually estimate how many of those tags were available to the herons, we figure a lot of the consumption happened in the lower 7 kilometers of the river. It works out between 1% and 5% as a minimum consumption estimate of all the Chinook smolts heading out. But what we don't know is if a heron eats a tag along the river, does that tag necessarily get deposited at the rookery, or is it deposited mid-flight or another area of the watershed? So that's one piece that we need to narrow down. But certainly something that's a more exciting part of what we found in the freshwater. And then I'll give you a little precursor here. There's more tags found at other rookeries, and some of them do not belong to us. So it's a cool story that's evolving. Now, this is shifting to just our marine survival results. So again, we did all this tagging work to see who's coming back and what relative rate of survival are these fish experiencing or showing us. So the red in this graph, simply the red bars just represent all the size bins of juvenile Chinook we tagged in Cowichan Bay in 2015. So we have the majority of our fish are between 80 and 90 millimeters. You have some kind of average ones, 70, 80, a few above average, and then some outliers that are like the real big ones, around 100, 110 mils, and also some really small ones. But within all those groups, the blue and yellow bars represent fish that actually come back to us. So what this is showing us is that although, yes, there's a slightly higher rate of return on the group that's 90 to 100 millimeters, we are seeing fish coming back from every tag group that we put out. So it's not just the big fish that are surviving, it's the small fish as well, and it's the medium fish as well. So it's not really a clear indication that only the big fish survive. It's actually survival's distributed across most of the size group bins that we encounter. So here's kind of the big result we're looking for is, okay, what's the relative survival from each of those different locations that we applied tags? So the ones in the river, and then we follow them out into the Cowichan Bay, so the nearshore environment's the beach seining, purse seinings in the center of Cowichan Bay. So again, as these fish move out, time's going on. And then the micro-trolling work, which I'm sure you've heard some about, occurs mainly in September, and those fish now are around 6 inches long, give or take. And these are how many fish to date have come back from both wild and hatchery tag groups. One of the things you'll notice is obviously survival increases over time and as fish head out, so we get more and more fish back later on as we would have expected, but also that wild fish are surviving about 3 times the rate, or returning at about 3 times the rate as hatchery fish, which is interesting because those hatchery fish are typically larger at every single stage that we tag them. So this is one of the key questions is, where's the bottleneck, right? So where's the bottleneck to marine survival production? That was the whole point of doing this tagging work. Where are we losing these fish? Where does survival actually increase? And then once we know where that point is, we can actually go and find what is causing that. So again, in May, this is a typical size Chinook smolt. They're often referred to as fingerlings for an obvious reason here. That's almost the length of one of your index fingers, about 80 to 90 millimeters. By September, again, they're starting to actually look like real fish by that point, right? These fish are 6, 7 inches long. They look like a Chinook. They actually look quite healthy when you're holding them. You can't believe that their survival is only 3.5% to return. And then obviously at some point down the road, 3-4 years later, you get these fish back, but you have very few. So again, I just put this example of a bottle here just to get your imagination working. Now on the next graph I'm going to show you for a bottleneck. So you start with a large number of fish early on, you end up with very few later on, and obviously there's a kind of a decay curve there, a loss curve of, okay, we're losing fish here, we're down to 5 from 1,000, how do we actually get there? Well, when I flip our survival returns from each one of those stages around, what I said, okay, if we start with 1,000 fish, by each point here, how many do we actually have left, and how do you actually get from 1,000 down to 4 fish? So 4.4 fish represents 0.44% survival, which if we go backwards to this graph right here for hatchery fish, it's 0.4% there at the river. So from the river release to return is 0.4%. How do we get there? Initially, this is what our initial results are showing. This will change, but basically you start with 1,000 from the river. By the time you hit the beach, you only have 800 left. By the time they're capturing the purse seiner, we're down to 600. By the time we tag them at microtrolling in September, we still have 375 fish left. So how do we get down to 4.4? Well, the only way we can do that is if there's a massive loss between microtrolling and age 2. So again, that age 2 point is not from pit tagging work. That's from a coated wire tag results from hatchery fish. So this is just hatchery fish I'm showing. And that's basically how many fish are left at the point where either they're going to recruit to the fishery so they could be caught by recreational fishers or commercial fishers, whoever it might be, or there may be some loss to predation there or natural losses, or fish are actually going to return to adult. So the interesting part about this curve is between age 2 and adult, so between 20 and 4, is where all our fisheries management work is typically focused. That's where our fishing limits, catch rates, all that work goes into. All that focus is just between that stage when we have these massive losses between all the other stages. But the interesting part, the real take home here, is the loss between microtrolling and age 2 is estimated at 95% right now. So it doesn't really matter what goes on, or not so much what goes on earlier in their life. When you're pushing those fish through a 95% filter, no wonder you don't have too many left. So that's, again, where our initial results are showing the work is going here.
Can you say what microtrolling is for the whole group there?
So microtrolling is a new technique that Will Dogood from University of Victoria and I kind of pioneered. Essentially what it is we're using recreational fishing gear, so standard downriggers, cannonballs, small boats, to go out and sample juvenile Chinook. And the way we do that is we pretend we're commercial trollers. So basically we take fixed hooks on snaps, so they're leaders about 10 feet long, small little flasher, tiny little spoon, and we clip them on our downriggers every 10 feet. We have 6 per side, so we have 12 hooks at once. We troll around for 5 minutes, you bring up one side, see what you got. And it actually ended up being a very successful technique at catching fish, incorporating tagging into the process of how fast you can actually retrieve your gear, process fish, release them. Our peak capture rates are between 17 and 20 fish an hour. So we're processing like a fish every 3 minutes continually for about 100 hours effort. So that's an incredible catch rate. And it also lets us fish areas where you might not be able to get into with big sampling boats, like a 100-foot boat can't get in tight to shore in a rocky area, but we can get right in there. And it turns out those areas are pretty important to juvenile salmon. So it's a really new technique, but it's been incredibly valuable for us. So just continuing the story forward here, I kind of shown you now some of our initial results. But well, what I haven't shown you or suggested is some other locations where we found pit tags. So here's a map of, again, Google Earth, Cowichan Bay, the Heron Rookery there on the south side of Cowichan Bay for reference. But we've actually gone to some different areas now and scanned some beach shorelines to see, okay, are there any tags showing up here? And sure enough, this is several days work on Barrow Island. So it's a small island in Sansom Narrows. And then we've extended out further and gone to some different reefs. That was just in one day, we found 4 different tags out there. So, okay, it's like, well, why could there be tags showing up on some of these locations? Well, the reason we went there is because of this. So this is Barrow Island. It's home to a small colony of seals. We estimate between 40 and 60 animals are there. And sure enough, there's pit tags showing up there. So when we kind of take a step back and go, okay, well, we have this bottleneck now. It's sometime between September and age 2. It's actually a lot further past where we might expect some of those bottlenecks that existed before we started doing these studies, what could explain it? Well, there's been more and more studies come out suggesting that pinnipeds, specifically harbor seals, are playing a larger role than we may have expected in basically declining survivals of coho and steelhead, or coho, steelhead, and chinook. And basically our visits to those sites were just basically a test of, okay, well, if so, could we actually find pit tags? And we did. But a couple of pit tags here and there, it wasn't really the focus of our study. It was more just a validation of that hypothesis. But when you start thinking about what those tags actually represent, it gets pretty scary, because seals generally, to speak, don't like defecating on their haulouts. So you might have 100 seals, but you might only find 1 or 2 scats there on a given day. So you know you're only getting a very small portion of the scats, and then there's only a very small portion of the cowichan fish that are tagged. And the cowichan fish represent a small portion of all the chinook there. And not to mention too, that if a tag actually does get lucky enough to be deposited on that haulout, you can imagine a couple tidal cycles come and go, and that tag rolls off into the abyss and we'll never find it. So to go out one day and find that many tags is kind of a little bit startling to us. And I'll just leave you with one last thought here, is that this year in 2017, there was an acoustic tagging project that you may or may not be aware of, but we focused on exactly where we're doing this micro-trolling work, applying the pit tags. 80 juvenile chinook got tagged in September, and we tracked them through till essentially March 1 is when the batteries ran out. So that gives us a pretty good snapshot at what's happening in that overwinter period where not a lot of other studies have focused. And the results of that are just starting to come out now. But initially, we've got a lot of detections, and it looks like we've got a pile of data to go through. So I think there's going to be some exciting results there to pay attention to. So that's where I'm going to leave it. Thanks for your time, and on to the next.